Okay, this section is 3.2, measures of variation. Okay, we're going to talk about finding the range, variance, and standard deviation of data. So this is kind of an important section as we kind of talk about a new term, standard deviation, which you will hear over and over and over again. So this is our introduction to that. So you guys have heard what range is. You know what range is. It's the largest minus the smallest values of a distribution. And then the new things we're going to talk about is standard deviation and variance. They're one and the same, and they kind of talk about the same type of data. Okay, so the range. What is range? You know what this is. My arrow works here. Okay, largest minus the smallest value. Okay, only two data values are used in the computation, so you lose a lot of the data. It's easy to compute, but can be definitely affected by extreme values. So if you find the range of 10, 13, 17, 17, 18, you go 18 minus 10 is 8. So if I ever ask for the range, that's as simple as that has to be. Okay, the important part of this section, standard deviation. Okay, standard deviation and variance measure the spread of the distribution around the mean. Okay, so we're basically thinking, where's your mean and how far apart are the rest of the data? That's an important concept of statistics, especially as we move on in this semester. Okay, the formula for calculating the standard deviation, this is now the complicated one. Okay, if you actually look on your pink formula sheet, all right, you see the computation formula S. Okay, so that's not the computation one. That's the easy one. The sample standard deviation, and the one right above it is this one. Okay, all this says is you're going to take every x value and subtract the mean, and then we will square them all, and then add them all up because this is the Greek letter sigma, and then you divide by n minus 1. That's the complicated way, because it's not necessarily easy if you have like 50 some data points. So to do it the long way, I'm going to show you one example to do this the long way. Okay, you have to know the mean, so you have to calculate the mean. Okay, you subtract the mean from each data value, and I'm going to show you this in the next couple slides. Square each term, add up the squareds, divide by n minus 1. Okay, and then to get standard deviation, you'll take the square root. If you just leave it as a square, it is the variance. So I'm just going to do a simple problem. Okay, these 6 data points right here. Alright, I am going to show you how to calculate the variance or standard deviation. They're one and the same just by doing this. Alright, first of all, you need to know what your mean is, your x bar. Alright, once you calculate that, it's not so bad. So in this problem, our mean, okay, if you add them all up and divide by 6, 36 divided by 6 is 6. So I'm going to take each data point and I'm going to subtract it by the mean. So 2 minus 6 is negative 4. The 3 minus the 6 is negative 3. 3 minus 6 is negative 3. And so on all the way down. Okay? Here is your subtraction. And then you need to square each one of them to make it positive. Okay? Because if you actually just use this original one and you add them all up, okay, you're going to end up getting something basically 0. This is the way it's going to be. That's why we need to do the variance. It squares everything. Okay, so that we get positive numbers and we can get a guesstimate on how spread out our data is. Alright, then when you add up all of your differences, you get a magic number of 70. Okay, and then you need to divide it by n minus 1. So what is n minus 1? N is just the number of data points you have in there. So we have 1, 2, 3, 4, 5, 6. 6 minus 1 is 5. 70 minus 5 is 14. Okay, so your variance, now s squared is your variance, and it actually says that on your pink sheet as well. If you see sample variance is s squared, population variance is sigma squared, but the squared part is variance if I ask about that. And then how do you get just s by itself? You take the square root. So the square root of 14 is 3.742. So that is the standard deviation of these data points. Okay, and we'll kind of talk more about what standard deviation really is, but I'm just kind of telling you what the computation part is. Okay, so if I'm going to do this one more time with some very easy numbers, okay, we're going to do this again. So if I have 30, 26, 22, I tell you right now that the mean is 26. Okay, so just another example to show you what's going on. You have to subtract 26 from each of them. So 30 minus 26, 4. 26 minus 26, 0. 22 minus 26 is negative 4. Notice the sum would be 0. That's why we need to square them so they become positive. Otherwise, you'd have 0 and you would have no idea what your standard deviation or the spread is. Okay? Then you need to square it. 16 16 is 32. And now the variance. All right? We have our differences. The sum of our differences, this top part is the 32, but we need to divide it by n minus 1. Divided by n minus 1 is simply just 2 in this problem. So our variance is 16. Okay? So what is the standard deviation though? You just take the square root. So if you ever are given the variance, the standard deviation is just the square root. So in this case, the standard deviation, okay, is 4. The spread from the mean is 4. Notice you were 4 units away. Okay, it's not always going to be the spread to the farmost, but this is just a simple example on how this works. Now, why am I only showing you simple examples? Because imagine if you had to do this with like 50 data points. That would take you literally forever, and I would never make you guys go through that pain, even though you might think I put you through pain right now. Okay, so it's just very easy with simple ones, but statistics is nice because we give you computational formulas. Compute. Okay, we're going to use these things to actually compute them. All right, so you guys have this right on your pink sheet. You might want to star this right now, somewhere, some way. Find this formula and star it. And actually, you don't even have this variance one on there. You have this one, so I apologize. This is the one you guys need to find. The variance one is not on there. Notice this, the only addition is there's a square root. That's how you go from the variance to the standard deviation. So you need to find this sample standard deviation formula and box it or square it. I will make you do a long by hand way of calculating standard deviation on the test. Okay, so you're going to need to know how to use this formula. All right, so what is each part of it? Okay, x, just remember the data set. Not a big deal. The mean, we need to know how to use that. N is the number of data points. Okay. You're going to use technology, and I'm not going to make you sit through a lot of pain. Okay? So if I give you these numbers, actually what I want you to do right now is dump these numbers into a list on your calculator. So if you put them in there like list 1, okay, you put 4, 5, 5, 7, 4. Okay? Put them in list 1, and I want you to do the first variable statistics for list 1. You might want to pause this. I just want you to do this right now. So if you go to stat, calculate, and do the 1 vars stat, and then L1. Okay, and you push enter. You should find sum of x in there, and you should find sum of x squared in there. This 25 and this 131 should show up right away. It means in there, sum of x squared. Okay, all of that's in there. And then S of x, if you look on the bottom, okay, it is also in there, and that number is going to show up soon. All right, but you're not going to have to physically go through and do all of these computations in a table. Okay, I'm fine with you doing the 25 and the 131, but you're going to have to show this formula. Okay, so that's going to be the only real trick per se. All right, so to calculate it, you need to dump these numbers in here. So it's the square root sum of x squared. All right, what is the sum of x squared? 131 minus the sum of x. Now be careful. The sum of x is 25, and then you need to square it, and then just this first part is divided by n, and n in this problem is 5. And then all of that's going to be divided by 5 minus 1. Okay? So what I'm going to do now, okay, is actually do this by myself. So I'm going to pause for. Okay, so what I did is I just showed all the steps without kind of wasting a lot of time. So notice the 25 squared, I needed to do that first. That's 625 right there. And I'm going to use a different color as I kind of talk about this. Okay, then you have to go 625 divided by 5 first. So that's going to be the 125 that you see right here. Then you have to subtract the top. That's 6. 6 over 4 is 1.5. And then the square root of 1.5 is the 1.22. And if you actually look at your calculator, when you did the first variable statistics, you actually saw that the S of x, standard deviation of x, okay, is 1.22. And the calculator does give that to you, but remember, on a test, I am going to force you to use the formula and show me it by hand. But at least you get to check out and make sure that you are correct. So that is an option for you, and that is there. Okay? So we go into more things in here. Population variance, standard deviation. Okay, when you're dealing with the entire population, you're going to use a capital N. It's just the type of problem that you are. This is just more or less talking about this. So you're going to have the mu, which is the Greek letter. So if you're ever dealing with the entire population as mu, you'll have the small Greek letter S sigma. Okay, population standard deviation is still the square root of the variance. The process is exactly the same. It's just that if you ever happen to use an entire population, that's what it's going to look like. The odds or the amount that will actually happen is about 0. Most of the time in this class, we're going to be dealing with a sample and focusing just on a sample. Okay, so the coefficient of variation. All right, why is this important? It's difficult to compare standard deviations. All right, from one different population to another because the units that things are measured in might be different. So to compare, okay, we can use the coefficient of variation, all right, to express standard deviation as a percentage of the mean. You're going to end up getting a percentage with the coefficient of variation. It's unit free and can be used to compare the spread, okay, of a sample. Now, how is this calculated? Now, this is also on your salmon sheet, not salmon sheet, I'm used to trig here, pink sheet, sample coefficient of variation, okay, S divided by X bar. Now we should know by now that S is just your standard deviation, okay, X bar is your mean, times it by 100 to get your percentage, okay, this is for the sample, this is for a population, this is still the standard deviation, the mu is still the mean, so the process is the same, standard deviation divided by mean, times by 100, and this is going to show what's more consistent or what's more variable in a certain scenario. Now I'm going to give you a concrete example. Let's say you have a newborn infant, had a mean weight of 6.2 pounds with a standard deviation of 1 pound. Okay, so if you're going to compute the coefficient of variation for this, you need to set it up as standard deviation divided by X bar times 100. So standard deviation, I tell you right now, standard deviation of 1 pound, 1 over the mean, 6.2 pounds, times 100. If you go 1 divided by 6.2, you get 0.16. Times that by 100, approximately 16%. Okay? 3-month-old. Big difference between a 3-month-old and a newborn. I know this right now because my son just turned 4 months old. Okay, so there's a different population, a different scenario. Weight gain's different. Okay, so we want to just compute this to see what's more variable. Okay, who's more variable in weight, newborns or 3-month-olds? So the average is 10.5, standard deviation of 1.5. So 1.5 over 10.5 times 100. If you do the math, 1.5 divided by 10.5. Okay, that ends up being 0.14 about times 100, so approximately 14%. Alright, if you look at the next slide, okay, the higher the percentage, the more variable in weight. The lower the percentage, the more consistent it is. So if you're asked that question and you're comparing, you would say the percentage that's higher is more variable. Okay, there's bigger change there. The number is larger. And that's what you want to do on that. So that is coefficient of variation. You're going to see that throughout this chapter. Okay, so that's one way to see that. The last thing, now we're kind of getting into proportion of data that's within standard deviations. And this is important as we move on into a couple other chapters. And this is one theorem, Chebyshev's theorem. Okay, this guy has way too much free time and he figured out that 1 minus 1 over kth, whatever, however many standard deviations you want to go, okay, this percentage of data is within that amount of standard deviations. So how this works, let's say you're looking at 2 standard deviations away. He thinks that 1 minus 1 over 2 squared, essentially 3/4 of your data, okay, is within 2 standard deviations. Alright? Within 3 standard deviations, 88.9%. Or 4 standard deviations, 93.8%. Now there's a couple other theorems as this class progresses that uses this kind of idea, but you will see that in a mere moment. Alright, so I kind of spell this out for you. So all of it, 2, 3, and 4, depending upon what you're looking for. Now what does this mean? Why is this important? Here's a concrete example. Let's say we have a math class that has an exam. Found that the mean is 77. The standard deviation is 6. Okay? So according to Chebyshev's theorem, now you're going to need to know this, so it's important to kind of think about this. If I say 75% of the grades, you got to make the connection that, okay, Chebyshev 75 means that it's 2 standard deviations away. So at least 75% of the grades would be in some interval. Now what does this mean? We have to figure out 2 standard deviations away. Okay? 6 times 2 is 12. And we want to make an interval. It's as simple as this. You're going to take your mean. I'll just put this all the way down. Okay? Take your mean, which is 77. We're just plugging it in. And then you go 2 times 6, or 12 units. You're going to subtract it and add to it to make an interval. So you have your mean in the middle. And then we're going to go 12 to the right, 12 to the left, and this makes an interval. So if 77 is your middle, you're going to go 65 to 89. Which means on this test, 3/4 of my class had a score within 65 and an 89. Okay? That's all it is. If it was 3 standard deviations away. Okay, so if it was 89 or 88.9%, then you would put a 3 in here, and it would turn into 18 each way. Or if you want to get, all the way up to 93.8%, be a little more specific, the interval is going to have to grow even larger. That's what standard deviation is, a distance from the mean, and some of these theorems are used to kind of calculate or give a broad range interval. So we're thinking 75% of the data is with, between 65 and 89 on this particular test. So we will work on this homework in class. I hope you guys have a wonderful day.